All right. Welcome to our presentation on satellite communication by Jack Hundley, Robert Alcock, and Jonathan Markham. For a quick introduction and overview, we'll go over what is satellite communication. It is the transmission of information between locations on Earth using artificial satellites orbiting the planet, or a global information system that collects, processes, transmits, and distributes information across large geographic areas. Some of the key functions of satellite communication include voice communication, television broadcasting, internet connectivity, navigation services, and weather monitoring. Now, why satellite communication matters? The importance is it connects remote and rural regions, supports global broadcasting, enables worldwide internet access, provides emergency communication during disasters, supports military and national security operations. The global impact is that billions of users rely on satellite-based services every day because everybody has a cell phone, everybody's connected to wireless connectivity, and it is critical. It has critical infrastructure for transportation, banking, and communication. The business value is that it enables global operations and increases business continuity during standard ISP outages. For a quick history and timeline of satellite communication, in 1957, Sputnik 1 was launched by the Soviet Union. This was the first satellite that was ever launched into space. In 1962, Telstar 1 enabled transatlantic television broadcasts. In 1965, Intelsat 1 became the first commercial communications satellite. And throughout the 1970s and 1990s, expansion of television and telecommunication networks took place. In the 2000s, growth of broadband satellite internet happened. And in 2019 to the present, low Earth orbit or LEO satellites have exploded. They've sent thousands of these low orbiting satellites into the lower atmosphere to enable connection from anywhere. Now, how satellite communication works. The communication process has four steps. Step one needs a ground station to send a signal or an uplink. Step two, the satellite receives the signal. Step three, the satellite amplifies and retransmits the signal. Step four, the receiving station receives signal or what's called the downlink. The key concept here is the satellite acts as a relay station in space.
Now that we've discussed the economic benefits of satellite communication, we should look at a real-world example of how this technology is actually being used today. So Starlink is a satellite internet service operated and created by SpaceX. It was created to address the problem that rural and remote areas often lack any internet service or it's not reliable. The solution was to deploy thousands of low Earth orbit satellites to provide internet connectivity worldwide. The business impact involves that it supports remote businesses and workers in areas that previously couldn't operate business just due to the lack of connectivity. It also improves disaster recovery communications. When a natural disaster strikes, it can often damage, destroy, or at least limit the ability for traditional communication networks to be reliable. And again, it expands access to the underserved markets, to especially underdeveloped countries or developing countries that just don't have the infrastructure that we're fortunate enough to have here. They now at least have the ability to access the internet and potentially start a business or just rely on all the information that we gain having access to the internet. From an information systems perspective, it demonstrates how technology creates organizational value by improving communication and access to information. But it doesn't come without costs and challenges. For the financial cost, it's manufacturing, developing the satellites, they're not cheap, and you need a lot of them to offer, especially the low Earth orbit. mega constellations. It requires thousands of them to offer worldwide coverage. You have the launch expenses. Obviously, launching a rocket, it's not cheap. And again, launching thousands of these satellites, it adds up. It's expensive. You have to build out the ground station infrastructure. Again, that's not cheap when the goal is worldwide coverage. And then you have the maintenance. All the ground station infrastructure, you need to maintain it, obviously, or it's going to fail. For the technical challenge, you have signal delays due to the distances being covered, less so with low Earth orbit constellations that are primarily being built now. You do have weather interference. When there's significant weather, it can disrupt the communication between the ground stations and the satellites themselves. And then both a technical challenge and a financial cost is the satellite lifespan limitations. In the environment of space, they don't last forever. So it does require one trying to build satellites that are going to last longer, but regardless, it requires replacing them and launching more while others deorbit. For the managerial challenge, you have regulatory compliance, especially in certain countries. Some of these services just aren't even approved yet. Um, so depending on where you're located in the world, you might not have access to some of these communication networks. You have vendor management, depending on, exactly who you're using to offer these services. Technology integration, that's becoming less of an issue with the mega constellations operating today. Um, but you still have to have all the hardware specific setup to whatever the application you're using it is for. And then workforce training requirements, anyone using these services, um, the employees need to know how to operate them. For the risks and security concerns, you have cybersecurity risks. Signal interception is a big one. These signals, they travel a long distance, and nefarious actors could potentially interrupt them and decode them. But that's where encryption is hopefully going to stop that one, but it's not without a risk. You have hacking attempts, which is similar. If they're able to intercept any of the information, there's the potential for it to be hacked. And then you have data breaches, and this can be from the storage infrastructure, the ground stations. That's where most likely you're going to have breaches of this data. Then you have operational risk. You have space debris. Space debris has lots of natural debris, previous satellites that have been launched, different rockets that are orbiting for eventual deorbit. If you have a string of satellites that comes into contact with space debris, even if it's microscopic, the speed in which the satellites are moving can destroy the network. And we have solar storms, which modern satellites aren't as at risk for, but if there is a significant storm, it can still disrupt service. And then you have equipment failures, which again, it's inevitably going to happen. But you have to be prepared for that. And that's why, especially with the low Earth orbit mega constellations, the eventual goal is to have enough there where if you have a few satellites that become inoperable, you're still going to be covered by other satellites. You have privacy concerns. Data transmission security. This kind of goes back to the risk of it being hacked or intercepted. It's obviously people's personal data is at line and being transferred. So you have to have that concern. You also have government surveillance concerns. Th for instance, Starlink, the largest low Earth orbit satellite internet constellation, it's a US company, but there's the risk that it can be hacked by foreign nations. And then you have the environmental concerns. You have space debris accumulation. This is especially true as potentially more companies are going to start launching their own mega constellations, where we just have so many satellites in space that it can become cluttered, it can become dangerous for collisions, and it's something that is very much a concern for the space industry. We also have rocket launch emissions. Obviously, burning so much fuel within Earth's atmosphere, you're going to have environmental concerns with that. You have resource consumption and electronic waste. It requires a lot of satellites that don't last forever and need to be deorbited eventually after they've fulfilled their useful life. So that's just a lot of material that needs to be addressed as it deorbits, which hopefully will burn up in the atmosphere, but could end up in the oceans. And then you have light pollution affecting astronomy. The current satellites being launched are addressing that. They're not producing as much light as previous generation of satellites were, but this particularly is for low Earth orbit satellites. There is the concern that it's going to affect astronomical data because we're going to have such a clouded low Earth atmosphere. And then you have governance risks where you have regulatory uncertainty. Um, this again goes back to certain countries don't even allow these services to operate yet. Then you have the geopolitical conflicts affecting service availability. Right now, we have multiple wars going on in Russia, Ukraine, Iran against, Israel and the United States, where it's become controversial where exactly some of these services are being offered and how it impacts the geopolitical landscape of communication. For future trends, um, the biggest expectation is that low Earth orbit mega constellations are what's going to drive this space. Um, Mostly because they have reduced latency. You can have very quick connection services. They also offer very fast internet to, again, the rural and remote areas that previously didn't have any offerings. Um, Artificial intelligence is being used. You have automated satellite management. This is increasingly affecting the ability for these services to be offered at a better and more serviceable rate. You have 5G integration. This is something that doesn't exist yet, but it will likely exist soon, where your phone will directly be able to connect to these satellite networks. Um, Smaller satellites. Hopefully, this is going to lower deployment costs because you're going to be able to launch more satellites per rocket launch. It'll also have a lower astronomical effect for astronomy. And then just the overall space-based internet expansion, increasing global connectivity and the opportunities for rural and underdeveloped nations, remote areas that previously didn't have reliable internet access.
So what does this mean from a management perspective or managerial implications? Businesses should consider, or organizations should consider, uh, what? Evaluate business considerations, organizations should. Uh, So what are the managerial implications of satellite communication? Or organizations should evaluate satellite solutions for remote operations, consider cybersecurity investments, assess long-term costs and benefits, plan for integration with cloud and mobile technologies. And the strategic importance is that satellite communication is becoming a competitive advantage for organizations requiring reliable global connectivity. And in conclusion, some key takeaways are that satellite communication enables global connectivity. It supports telecommunications, internet broadcasting, navigation, and emergency services. It benefits, the benefits include worldwide coverage and reliability. Risks include cybersecurity threats and operational challenges. Future technologies will continue expanding access and improving performance. Here are some of our references, and thank you for listening.